So we are now spontaneously casting the problem. I want someone of you to tell me how much is 2000 cos 50. Bolo. Tell me how much is that. So I will ask someone. Adarsh, can you unmute yourself? Adarsh Sharma. Adarsh.
Yes, sir.
Yeah. Can you tell me how much is 2000 cos 50?
1285.57.
1285.57.
1285.
Yes, sir. 0.575.
1285.575.
575.
Okay. Just give me a minute. Are you able to see this? 600 Newton? Others?
Yes, sir.
Yeah. Okay. So this is 600. And now let us say now tell me what is 200 sine 50? Others?
153.21.
153.21.
21.
Let me give names. So let me call this point as A. This is A. This is B. This is C. And this is D. तो देखो क्या बोला है आपको, इन दिस प्रॉब्लम यू हैव बीन आस्क्ड टू कंप्यूट resultant of this force system which is shown at A and C. Are you with me, others?
Yes, sir. Yes, sir.
Okay. So as we have seen in the last class, when I ask you to find out the resultant at A or resultant at C, it is typically going to be force and couple system. Force भी रहता है और moment भी रहता है. Do you
Moment,
agree
yes.
with me? Hmm.
Yes, sir.
So it has two parts. Part A of problem number 17 is find out the result, compute the resultant at A, and part B of the problem number 17 is compute the resultant at C. Are you with me? And through
Yes.
this problem, I am going to demonstrate some conceptual understanding about the resultant of forces. So seldom in this class, in this course, we will see the theory in isolation. Theory will be the manifestation of problem solving. Are you with me?
Yes, sir.
Okay, chalo. So we will calculate, compute the resultant at A is the first part. So whether it is part A or part B, the first thing that I have to do is summation fx and summation fy calculate karna padega. Do you agree with me?
Yes, sir.
So let us try to do that now. Let us calculate Rx. Rx is x component of the resultant, force resultant, and that is going to be summation fx.
FX. Yes.
This Rx is force resultant at any point, whether it is A, C or any other point on or off the body. We are going to calculate summation fx as Rx. Do you agree with me? Force resultant remains unchanged. And that is how
Yes.
much? Can you tell me now? Let us consider forces one by one. So this 2000
2000 cos 50.
2000 cos 50. And is it positive or negative?
Sir, positive.
Yes, 2000 cos 50. Are you with me? Chalo.
Yes, sir.
Then positive because it is acting in positive x direction. So
Positive
first
X
of all, we
direction.
will have to define. So let me call A as the origin, and x axis is towards right and y axis up as positive. This is what I have defined if not given in the problem. Are you with me?
Yes, sir.
चलो, अब दूसरा फोर्स कौन सा है? 100 न्यूटन का कोई कंपोनेंट आएगा हॉरिजॉन्टल डायरेक्शन में? नहीं.
नहीं, sir.
53.21 का?
नहीं.
नहीं. This 600, what should I write? Minus
Sir,
600, right?
yes, sir. Minus 600.
Minus 685.575.
Yes.
तो जो लोग एकदम बारीकी से ऑब्जर्व कर रहे हैं उनको समझ में आएगा मैंने कैसे प्रॉब्लम सेट किया. बट नाउ यू कैलकुलेट दिस सम. सो हाउ मच इज दैट सम? टेल मी. हाउ मच इज समेशन fx? कंप्यूट.
Sir, 0.
Great. So summation fx turns out to be 0. Now let us find out ry. What is ry? Summation fy.
FY.
So देखो क्या आने वाला है.
So minus 2000 sin 50.
Minus 2000 sin 50.
Plus 100.
माइनस क्यों? क्योंकि ये डाउनवर्ड डायरेक्शन में जाएगा वर्टिकल कंपोनेंट. सो एज पर एज्यूम पॉजिटिव y इट इज नेगेटिव. देयरफॉर minus 2000 sin 50 plus 100 plus
53.21.
53.21. राइट. चलो बोलो क्या आता है. हाउ मच?
Minus 1378.88.
नहीं तो कुछ तो गड़बड़ किया आपने बताते वक्त. 2000 sin 50 कितना है बताओ. 2000 sin 50 कितना है?
1532.08.
हाँ 1532 है ना. ओके. 0.08 तो वो गड़बड़ हुई. तो इस 100 को 1000 कर दो in the problem setting itself. This should be 1000. Are you with me?
Yes, sir.
And this should be one minute. This should be 532.08. This force should be 532.08. दिस इज द प्रॉब्लम स्टेटमेंट. आर यू विथ मी?
यस सर.
सो अब क्या होगा, यहाँ पे 1000 आएगा और यहाँ पे
तो जीरो हो जाएगा.
532.58 आएगा, तो जीरो हो जाएगा.
जीरो. यस सर.
तो समझा आपको मैंने कैसे प्रॉब्लम सेट किया है. 532.08. To our surprise, Ry also turns out to be 0. So what is the force resultant? R is equal to square root of Rx square plus Ry square. Do you agree with me?
Yes sir.
Rx square plus Ry square. And how much is that? 0.
0.
And what is the angle that resultant makes with horizontal? Theta is equal to tan inverse of, bolo, 0 by 0.
0.
0 by
Yes.
0 is indefinite form. Do you agree with me?
Yes sir.
तो कर ही नहीं सकते. tan inverse of 0 by 0 is not infinity, mind you. If it would have been 2 by 0, infinity, fine. But 0 by 0 is indefinite form.
Yes sir.
हाँ, तो tan इनवर्स ऑफ 0 by 0 कर ही नहीं सकते, और वो करने की जरूरत भी नहीं है क्योंकि रिजल्टेंट है ही 0, तो कौन से भी डायरेक्शन में एक्ट हो क्या फर्क पड़ता है. Are you
Yes
with
sir.
me? So therefore, we are now in strange situation where the force resultant of all these forces is 0, and we tend to declare that this system is acted upon by a 0 resultant. And that's the problem, because you did not check what about the moment resultant. Are you with me?
Yes sir.
So now what are we going to do? We are going to now invoke, we are going to find out the moment resultant at A. Do you agree with me?
Yes sir.
And how do I do that? How do I find out moment resultant at A? By taking moments of all the forces at A. Are you with me?
Yes sir.
So moment resultant at A about Z axis. These are the moments about Z axis. ये resultant क्या है? ये अगर मुझे find out करना है तो मुझे क्या करना पड़ेगा? Summation of moments of all the forces about Z axis. Are you with me?
Yes sir.
Passing through A. Z axis passing through A. ये करना पड़ेगा ना?
Yes sir.
चलो अब जरा मुझे बताओ what are the moments. चलो quickly. What is the moment of 2000 about A? तो ऐसे देना मुश्किल है, because I will have to extend this line of action, drop a perpendicular, find out this perpendicular distance from A, and then that multiplied by 2000. लेकिन ऐसे नहीं करेंगे. हम क्या करते हैं? We resolve it into two orthogonal components. Are you with me?
Yes sir.
हाँ, तो रिजोल्यूशन के बाद कैसे दिखेगा? हॉरिजॉन्टल कंपोनेंट ऑफ 2000 is going to be like this. Do you agree with me?
Yes sir.
And
Yes
vertical
sir.
component is going to be like this. So I mark that. Now what is the moment of horizontal component? 2000 cos 50,
Cos
जिसके बीच
50
में
into
थीटा,
1000.
हाँ, जिसके बीच में थीटा वो एंगल cos थीटा. So 2000 cos 50 into 1000. And what kind of moment does it generate about A? Clockwise or anti-clockwise?
Sir, anti-clockwise.
No? अरे इमेजिन नहीं हो पा रहा है आप लोगों को अभी भी. This is the point. This is the force. It is going to generate clockwise moment.
Okay sir.
क्या कंफ्यूजन है बताओ? I will be able to help.
सर वो एंटी क्लॉकवाइज और क्लॉकवाइज कैसे, वो पार्ट नहीं समझा बस.
देखो
मतलब यही वाला. हाँ.
देखो, you hold the body at A, pin it at A, you hold it between your two, means it's bus, but imagine that you are holding it at A. Are you with me? And if
Yes
the
sir.
force is applied like this, how is the body going to rotate? Is it going to rotate in clockwise direction or anti-clockwise direction?
क्लॉकवाइज.
हाँ, क्लॉकवाइज वर्ड का मतलब तो समझा ना, क्लॉकवाइज और एंटी क्लॉकवाइज.
हाँ सर.
हाँ, so it will rotate in clockwise direction, so therefore the moment that must be produced is clockwise.
ओके सर.
अभी कोई डाउट है?
नहीं सर.
हाँ, अब जरा ये 100 किलो न्यूटन दे, 1000 न्यूटन दे. 1000 न्यूटन का फोर्स कैसे है? ऐसे है ना? आर यू
हाँ
विथ मी?
सर. यस सर.
Imagine that you are holding the body here. How does the body rotate under the action of this 1000 Newton? Clockwise or anti-clockwise?
तो क्लॉकवाइज.
अरे नहीं ना, कैसे? ऐसे जाएगा ना बॉडी. आर यू विथ मी?
यस सर.
तो ये एंटी क्लॉकवाइज है ना. 12.
सर बट वो ए के केस में हम लोग वो राइट साइड को पुश कर रहे थे ना बॉडी को.
No, no. Let me put my video on. 1 minute. This is crucial point. Are you able to see me now?
Yes, sir.
So this is the body under consideration. Do you agree with me? ऐसा ही है.
Yes, sir.
This is the point.
Yes, sir.
यहाँ पे मैंने होल्ड किया है. Are you with me?
Yes, sir.
और उल्टा हो रहा है. कैसे हो रहा है? That's correct. No, for to show it to you, this is the point, A point. Do you agree with me?
Yes, sir.
हाँ, ये A point है और इसके ऊपर ये 100 न्यूटन का फोर्स एक्ट हो रहा है ना, ऐसे वाला.
हाँ.
Are you with me? तो ये
Yes.
कैसे रोटेट हो रहा है आपके हिसाब से? क्लॉकवाइज है, एंटी क्लॉकवाइज है?
एंटी क्लॉकवाइज.
हाँ, तो ये फोर्स कैसा मोमेंट प्रोड्यूस करता होगा? एंटी क्लॉकवाइज. डू यू एग्री विथ मी?
यस सर.
हाँ, अब जरा ये 2000 का कंपोनेंट देखते हैं. 2000 का वर्टिकल कंपोनेंट कैसे एक्ट हो रहा है? ऐसे एक्ट हो रहा है ना,
डाउनवर्ड्स. यस सर.
हाँ. नाउ अबाउट दिस पॉइंट, हाउ इज इट रोटेटिंग द बॉडी?
क्लॉकवाइज.
हाँ, तो अभी कुछ दिक्कत है?
नहीं सर.
हाँ, 2000 का हॉरिजॉन्टल कंपोनेंट कैसे एक्ट हो रहा है? ऐसे एक्ट हो रहा है ना.
यस सर.
हाँ, तो अबाउट दिस पॉइंट, हाउ इज इट रोटेटिंग द बॉडी?
एंटी क्लॉकवाइज.
अरे ये देखो. हाँ, आई एम सॉरी. 2000 का हॉरिजॉन्टल कंपोनेंट कहाँ पे एक्ट हो रहा है वो गलत दिखाया मैंने. दैट्स व्हाई देयर वाज ए प्रॉब्लम. हाँ, 2000 का हॉरिजॉन्टल कंपोनेंट ऐसे एक्ट हो रहा है ना.
यस सर.
हाँ, तो हाउ इज इट रोटेटिंग द बॉडी?
तो क्लॉकवाइज.
हाँ, तो अभी कुछ डाउट है?
नहीं सर.
हाँ, किसी को कुछ डाउट नहीं है इसमें? शैल वी प्रोसीड? हेलो.
हाँ सर. आई हैव नो डाउट्स.
You have a doubt? Yeah, ask me.
Sir, no doubt.
No doubt.
No doubt.
Okay. So you have to imagine this. You are holding a body at a point, and then what force causes which kind of rotation? उसके हिसाब से साइन देना है. Are you with me? Clockwise या anti-clockwise decide करना है. So now tell me, horizontal component of this force 2000, what kind of rotation does it produce at A? Clockwise. Agreed?
So yes sir. Minus sign.
हाँ, so माइनस साइन आएगा. तो कितना है वो? 500 2000 cos 50
cos 50 into 1000.
Very good. So
minus.
this yeah, so minus, tell me, 2000
cos 50 into 1000.
cos 50 into 1000. Are you with me?
Yes sir.
Okay. Now what kind of moment does 2000 sin 50 cause about point A? Clockwise.
Yes sir.
देखो, और एक छोटा सा ट्रिक मैं आपको बताता हूँ. मन ही मन में ये करना. क्या करना है? यू ड्रॉ दी पॉइंट. पॉइंट कहाँ पे है? दिस इज पॉइंट ए. आर यू लुकिंग? 2000 sin 50, where is it acting? It is acting here. Do you agree with me?
Yes sir.
2000 sin 50. हाँ. तो अब अगर मैं बॉडी को यहां पकड़ू तो इस फोर्स के वजह से क्या बॉडी ऐसे नहीं मूव होगा?
होगा सर.
हाँ, सो देयरफॉर क्लॉकवाइज. समझ में आया अभी? कोई डाउट नहीं है? ओके. सो देयरफॉर माइनस 2000
तो प्लस
क्लॉकवाइज है ना. क्लॉकवाइज माइनस
सर. हाँ
2000 sin 50. Mind you,
500.
moment when you give sign, it is not the sign of component. It is the sign of moment caused by the component.
Yes sir.
And this multiplied by what? कितना distance है?
500.
You have to find out perpendicular distance between line of action of force and A. That is 500. Are you with me?
Yes sir.
Great. चलो, किसी को भी at any point of time कौन सा भी doubt हो, how much ever silly you may think it is, you have to get it clarified. Are you with me? My job
Yes,
is
sir.
precisely to clear your doubts till the last drop of my blood. Therefore, कोई भी doubt है तो पूछो. Stop me and ask me. So 2000 cos 50 into 1000, 2000 sin 50 into 500. Are you with me?
Yes sir.
Now what about this 1000? What is the moment caused about A? फिर से वही करेंगे.
Anti-clockwise.
I will show this 1000 here. About A, what kind of moment does it cause? It causes anti-clockwise moment. Do you agree?
Yes sir.
So therefore ये क्या होगा? Plus 1000 multiplied by
1500.
yes, very good. So when you are talking about vertical force, you are going to find out horizontal distance from point of application. Are you with me?
Yes sir.
Yeah, somebody was speaking. Any doubt? Okay, let's go ahead. So 1000 multiplied by 1500. Now what about this 685? This is 685.575. Do you agree with me?
Yes, sir.
What kind of motion does it produce about A?
Anti-clockwise.
Anti-clockwise. Therefore, I'm going to call this as positive. And what is the magnitude of moment? 685.575 into 1500. Are you with me?
Sir, 3000.
Why 3000? Just though I said, no, when you are calculating moment of horizontal force, you should look at vertical distance. Dekho, I am extending the line of action of this force.
Yes, sir.
And
Yes.
from A, if I drop perpendicular on this line of action of force, what is the distance? It is 1500.
Yes.
Am I clear?
Yes.
So therefore, plus 685.575 multiplied by 15. Great. What else? You have now this 532.08. Agreed?
Yes, sir.
So what is its moment?
Anti-clockwise.
चलो यहाँ पे लिखता हूँ 532 point. This diagram that I am drawing here, now that should be drawn in your mind. इसका रियाज करो. Are you with me?
Yes,
532.08. तो क्या करना है अब? ये कैसे होगा? एंटी क्लॉकवाइज. Do you agree with
Yes,
me?
sir. Yes.
So therefore plus 532.08 multiplied by 3000.
Zero.
अब 3000 सही है.
3000.
So 532.08.
अभी नहीं.
Pardon? 08, right?
Yes.
Multiplied by 3000. Great. तो ये हो गया. और कौन सा फोर्स बचा है? 600. Don't commit silly mistakes. कोई भी फोर्स मिस नहीं करना है. सारे फोर्सेस देखने हैं. 600 now. I will show that 600 Newton force here. What kind of moment does it produce about A? देखो ऐसे वाला है. ऐसा मोमेंट प्रोड्यूस करेगा. Are you with me?
Yes, sir. Yes, sir.
So
Clockwise.
what is that moment? Anti-clockwise. So therefore, I will write down that as plus. And what is that? 600 multiplied by 1000. Are you with me?
Yes, sir.
Line of action of 600 extended. From A, I am going to drop the perpendicular and I get 600 into 1000. Happy?
Yes, sir. Yes.
So now do this calculation. At least two of you should give me independent answers so that we will cross verify. How much is this? So this is equal to. Do this and tell me. Ensure that your calculators are in degree mode.
So 2672982.84.
267,298 point.
2982.
Okay, 2982.84.
84.
And what will be its unit? फोर्सेस किस में सब्स्टिट्यूट किया आपने? न्यूटन में.
न्यूटन.
और डिस्टेंस किस में सब्स्टिट्यूट किया? एमएम में.
हाँ, mm.
हाँ, so it is important to write down the unit. Unit will be Newton mm. Are you with me? Force multiplied by distance. So Newton mm. Happy?
Yes. Yes.
And what is its sign? Its sign has turned out to be positive. Is it correct?
Yes.
And therefore it is anti-clockwise. Are you with me?
Yes, sir.
Therefore anti-clockwise. Now I want independent confirmation. So one other student must tell me that this number is correct. Then we will.
Yes, sir, it's correct.
Great. So therefore, what is the resultant at A of this system? So what is the answer? Resultant at A, force resultant at A is 0. Do you agree with me?
Yes, sir.
And moment resultant at A about Z axis, now that is understood, that is equal to how much? 2672982.84 Newton mm anti-clockwise. Are you with me?
Yes, sir.
This is the resultant. So you have to understand that this is the system where the system has only moment resultant, no force resultant. Are you with me?
Yes, sir.
मतलब ये बोलने के लिए सब ठीक है. What does it actually mean? वो समझने के लिए next part of this problem और फिर से solve करते हैं. So we are going to solve now this part, second part, B. So to solve B part, what is the first step? First step is to find out force resultant, and that we have already done. So I am going to borrow that step here. Are you with me?
Yes, sir.
So that this is what we are going to do, and you will understand that force resultant is going to be 0 everywhere. Any point you take on the body of the body, the force resultant is going to be 0. Agreed?
Yes, sir.
Force resultant 0 है मतलब under the action of these forces the body doesn't have tendency to translate. Translation की tendency नहीं है. Are you with me?
Yes, sir.
तो कौन सा भी पॉइंट बॉडी का 1 इंच भी ट्रांसलेट नहीं होगा एक्स वाई जेड एक्सेस के अलावा, सिर्फ रोटेशन की टेंडेंसी है. आर यू विथ मी? बिकॉज मूवमेंट इज नॉन जीरो. अब जरा कैलकुलेट करते हैं कि ये जो रोटेशन की टेंडेंसी है वो सी के यहाँ कितनी है. व्हाट इज द मोमेंट ऑफ ऑल दीज फोर्सेस एट सी? आर यू विथ मी?
यस सर.
सो आप ही अब मुझे बताने वाले हो इक्वेशन. सो आई एम गोइंग टू राइट डाउन नाउ मोमेंट about z axis through C. Are you with me?
Yes, sir.
Z axis passing through C. How much is that? So सारे forces के moments लेने पड़ेंगे. So what is the moment? अब जरा फिर से ये diagram मैं यहाँ बनाऊंगा. Let me take this diagram down as well, so that will be easy to handle. Just a question: is my handwriting readable?
Yes, sir.
Okay. ठीक है. अगर किसी को handwriting में problem है वो भी बताओ. I will try to improve. हाँ ना. So problem number 17. आगे चलते हैं. So how do we go about it? C के यहाँ मोमेंट लेना है. तो C कौन सा पॉइंट है? This is the point under consideration. This
Yes,
is
sir.
C. Now in with reference to this point C, 2000 का horizontal component कहाँ पे lie करता है? यहाँ पे. Do you agree with me?
Yes, sir.
And that is going to be equal to 2000 cos 50. Happy?
Yes, sir.
What kind of movement does it produce about C?
Anti-clockwise.
Anti-clockwise. So I am going to write down plus sign. So plus 2000 cos
50
multiplied by 500.
500.
Do you agree with me? क्योंकि
Yes,
देखो ये
yes.
डिस्टेंस 1000 है तो what must be this distance? This
500.
distance must be 500. Happy?
Yes, sir.
चलो 2000 का जो वर्टिकल कंपोनेंट है, हाँ बोलो.
Anti-clockwise.
नहीं, वो एक्ट कहाँ पे होगा? इसी पॉइंट पे एक्ट होने वाला है ऐसे.
हाँ नीचे.
हाँ. And it is also going to produce anti-clockwise.
Anti-clockwise.
So I will write down plus 2000 sin 50 into अब डिस्टेंस क्या होगा? नो 500. नाउ वर्टिकल फोर्स है तो उसका हॉरिजॉन्टल डिस्टेंस लेना पड़ेगा.
So 1000.
250.
2500. 2500.
2500. Are you with me?
Yes, sir.
चलो, तो ये फोर्स हो गया. नाउ व्हाट अबाउट दिस 1000? This 1000 is acting where? It is acting somewhere here. So what kind
Yes.
of movement does it produce about C? Clockwise.
Yes.
Do you agree with me?
Yes, sir.
So minus 1000 multiplied by ये डिस्टेंस कितना है? 1500.
150.
1000 multiplied by 1500. चलो अब आगे.
600.
600 कहाँ पे एक्ट हो रहा है? कंपैरिजन नहीं, 600 is towards left but down this point. Are you with me?
Yes, sir.
And it is going to cause clockwise movement.
Clockwise. Yes, sir. Yes, sir.
So minus 600 into बोलो डिस्टेंस.
500.
Yes, 500. अब आगे
532.08.
will it cause any moment about C? No, because it is passing through C
No, sir.
itself.
Same. Yes, sir.
Its line of action is passing through C.
Passing through C.
685.575. Will it cause any moment? No, because its line of action
No,
is passing through C.
C.
Are you with me?
Yes,
So
sir.
therefore, what I have to write is plus 532.08. ये
Into
एग्जाम
zero.
में लिखने की या कंसिडर करने की जरूरत नहीं है, पर यहाँ अंडरस्टैंडिंग के लिए हम कर रहे हैं तो मैं लिखता हूं प्लस 685.575 into 0. Are you with me?
Yes, sir.
So now calculate this. How much is this? Tell me.
Sir, 2673009.825.
1 minute. Give me a second. फिर से कैलकुलेट करो, कुछ तो राउंडिंग ऑफ में गड़बड़ किया है, या ऊपर के केस में राउंडिंग ऑफ में गड़बड़ होगा. इट्स ऑल राइट, नो इश्यूज. कितना आ रहा है बताओ आप. So moment about C. Tell me how much is that?
2673009.825.
2673
009.
हाँ
0.825.
825 Newton mm. Are you with me?
Yes, sir.
And positive आया ना,
हाँ,
so
sir,
therefore
correct.
anti-clockwise. हाँ, अब जरा देखो ये राउंडिंग ऑफ के वजह से आंसर्स डिफरेंट आए, बट इफ यू ऑब्जर्व दिस नंबर इज वेरी क्लोज टू दिस नंबर 2673. ये 298 है, so it is very close. Do you agree with me? 267300 and 2672982 is very close. This error can occur due to rounding off. Are you with me?
Yes, sir.
So if you do rounding off everything correctly to the, let us say, 4 or 5 decimal places after means after 4 to 5 decimal places, you will get this number exactly equal to MA. Are you with me?
Yes, sir.
So what is the observation? Whether I take point A, whether I take point C, whether I take point B, point D, or any other point in this plane, I am going to have the same resultant. Force resultant 0 and moment resultant same. Are you with me?
Yes, sir.
You can prove that. Means I will give you homework. You can do it for B and D, and you will find that you will get the value very close to MA and M. Due to rounding off, you will get something different, but otherwise it is exactly same. MA, MC, MB, MD, everything will be same. You take this point, it will be same. Are you with me?
Yes, sir.
So what is the observation? Unlike the previous problem, where the moment resultant was changing from point to point. Do you agree with me?
Yes, sir.
यहाँ पे क्या हो रहा है? Force resultant is 0 and moment resultant is same at
Yes.
all points on the body.
Yes, sir.
अब ये ऐसे क्यों हुआ होगा, अब बताओ मुझे. What can be the reason? And that reason is the point to cherish. वो सबसे important conceptual point है. Are you with me?
Yes, sir.
हाँ.
सर तो मतलब कोई भी बॉडी पे मतलब कभी भी फोर्स रिजल्टेंट 0 है तो मोमेंट हमेशा कहीं पे भी लगा है सेम रहेगा ना पूरे बॉडी पे.
यस यस. और वो क्यों होता है? तो जरा देखो,
हाँ.
फोर्स रिजल्टेंट 0 होने का मतलब क्या है. यहाँ पे जो 2000 न्यूटन का फोर्स था वो फोर्स छोड़ दो. हाँ. एंड इफ आई टेक रिजल्टेंट ऑफ ऑल अदर फोर्सेस लाइक दिस 1000, then 532.08, 685.575 एंड 600, इनका रिजल्टेंट लू तो वो भी 2000 आना चाहिए और इसको पैरेलल आना चाहिए. डू यू एग्री विथ मी?
हाँ सर.
तो ही तो समेशन इस डायरेक्शन में भी 0 होगा. आर यू विथ मी?
यस सर.
आर्ग्यूमेंट देखो क्या है. समेशन एफ एक्स इज 0, summation fy is 0, rx is 0, ry is 0, therefore r
Zero.
is 0. If r is 0, you take the sum of forces in any direction, it has to be 0. Do you agree with me?
यस सर.
हाँ. तो इसका मतलब है अगर मैंने 2000 का फोर्स कंसिडर किया और बाकी के सारे फोर्सेस को एक रिजल्टेंट में कन्वर्ट किया तो वो 2000 ही होना चाहिए और उसके अपोजिट डायरेक्शन में होना चाहिए. Do you agree with me?
यस सर. यस सर.
And there will be some perpendicular distance between lines of actions of these forces. Do you agree with me?
यस सर.
So what is the moment resultant? Is it a moment of a force or is it moment of couple of forces? It is moment of couple of forces or couple moment. और हमने जब कपल मोमेंट डिस्कस किया था तभी मैंने आपको बताया था कि कपल मोमेंट का मैग्नीट्यूड रिमेन्स अनचेंज्ड एनीवेयर ऑन द बॉडी. डू यू रिमेंबर दैट?
यस सर.
हमने दो चीजें सीखी है, मोमेंट ऑफ ए फोर्स और दूसरा है कपल मोमेंट. मोमेंट ऑफ ए फोर्स चेंजेस फ्रॉम पॉइंट टू पॉइंट, नॉट ओनली इन मैग्नीट्यूड, इट मे चेंज ऑल्सो इन डायरेक्शन. ये हमने डिस्कस किया था, याद है?
यस सर.
That is similar to the previous problem where जो हम point पे moment ले रहे थे that was moment of a force, but यहाँ पे as the resultant is 0, there must be two forces in any direction under consideration which are equal and opposite and separated by distance, and they must produce couple moment. और जो कि couple moment produce हो रहा है, the body is subjected to only pure rotation and its magnitude is same everywhere. Are you with me?
यस सर.
दिस इज कॉल्ड एज टीचिंग ऑफ द कंसेप्ट. हमने सेपरेटली मोमेंट ऑफ ए फोर्स की कंसेप्ट सीखी है. इसके बाद आप मोमेंट ऑफ ए फोर्स के कंसेप्ट का लेक्चर सुनो. देन यू ऑल्सो लिसन टू मोमेंट ऑफ कपल ऑफ फोर्सेस लेक्चर. वी हैव clearly mentioned there that moment of a force changes in magnitude and or direction at point to point, from point to point on a body, but couple moment remains same throughout that plane everywhere in the body. Are you with me?
यस सर.
हाँ. सो ये जो प्रॉब्लम मैंने दिया है ऐसे प्रॉब्लम नंबर 17, that is in fact a couple moment acting on a body. Therefore translation tendency is 0 anywhere at any point. So in other words, I can say if a system is acted upon by coplanar non-collinear forces and if the force resultant turns out to be 0, then it is likely that the body is subjected to non-zero couple moment. Are you with me? Moment भी 0
Yes,
हो
sir.
सकता है, that is very special case, but otherwise it is subjected to couple moment or moment of couple of forces, and the body has a tendency only to rotate at every point by the same effort. Are you with me?
यस सर.
इसका फिजिकल डेमोन्स्ट्रेशन भी मैं दे दूंगा. फॉर दैट आई एम गोइंग टू नाउ स्विच ऑन द वीडियोस. स्विच ऑन द वीडियो. आर यू एबल टू सी मी?
यस सर.
हाँ. तो अब जरा देखो, एट दिस एंड आई एम गोइंग टू पुल दिस बॉडी अप एंड एट दिस एंड आई एम गोइंग टू पुश इट डाउन. आर यू विथ मी?
यस सर.
And by same effort. So I am going to pull it up by force F. I am going to push it down by force F. So nowhere there is a tendency to translate in this direction. Are you
Yes,
with me?
यस.
But there is a tendency to rotate. देखो कैसे रोटेट हो रहा है. देखो मेरे लिए क्लॉकवाइज, आपके लिए एंटी क्लॉकवाइज. है ना?
यस सर.
अब जरा एक काम करते हैं. हेलो.
So that's not me, sir. That is Aftab maybe.
Okay, fine. Now, what I am going to do is I am going to apply the same forces in same directions but at different points. Are
Yes.
you with me? यहाँ पे. So I am going to pull this up and push this down by the same effort. Lever arm has not changed. The distance between the forces has not changed. Their magnitude is not changed. Are you with me?
Yes, sir.
Is it going to have same effect on the body?
Yes, sir, but a different direction.
No, same direction. देखो
Sir,
ये भी ऐसे ही था,
oh,
कुछ चेंज ही नहीं
yes.
किया है, तो सेम ही
हाँ, sir.
डायरेक्शन होगा ना. सो इसका मतलब है कपल मोमेंट कैन बी ट्रांसपोज एनीवेयर इन इट्स प्लेन. कपल मोमेंट अगर बॉडी के ऊपर एक्ट हो रहा है, इट कैन बी ट्रांसपोज एनीवेयर इन इट्स प्लेन एंड इट स्टिल हैज सेम इफेक्ट्स ऑन ऑल पॉइंट्स ऑफ द बॉडी. आर यू विथ मी?
Yes, sir. Yes.
सो वन इंपॉर्टेंट स्टेटमेंट दैट वी आर गोइंग टू राइट डाउन नाउ इज, देखो इसके पहले वाला स्टेटमेंट ये था, on rigid body the force can be transferred anywhere along its line of action. अगर फोर्स ऐसा है तो we can transfer the force anywhere along its line of action without having different effect on the body. It will have same effect. Are you with me? For rigid bodies. Are you
Yes,
with
sir.
me? This is
Yes.
called as transmissibility of the force. Transmissibility of force. That means if rigid body is acted upon by force F, I can translate this force or transmit this force along its line of action anywhere,
Action.
and it will not alter the effect on all points of the body. The effect will still remain the same. Are you with me?
Yes, sir.
So it is called as transmissibility of the force. अब दूसरी चीज देखो, there is a body on which I am applying two equal and opposite forces F. इसी ट्रांसमिसिबिलिटी से व्हाट आई सेड कैन बी प्रूव्ड. देखो ट्रांसमिसिबिलिटी का मतलब क्या है, इसी फोर्स को मैं इस लाइन ऑफ एक्शन के अलोंग कहीं भी ट्रांसफर कर सकता हूं. डू यू एग्री विथ मी?
Yes, sir.
So I transmit this force along the line of action and I apply it here. Happy?
Yes, sir.
And I transmit this force here and I apply it here. So the effect produced by this couple is going to be same as effect produced by this couple.
Yes, sir.
Are you with me? So this is
Yes.
called as transposability of the couple moment. That means moment of couple of forces or couple moment can be transposed anywhere in its plane without altering the effect on any point of the body. Are you with me?
Yes, sir.
That I will write down. Couple moment. ये आपको couple moment के टाइम ही बताया जा सकता था when I taught it, but then it would have been just a theory. I just proved it to you now through an example. Are you with me?
Yes.
So couple moment can be transposed anywhere in its plane, anywhere in its plane without altering its effect. Are you with me?
Yes, sir.
Effect. So now we have to solve few more problems based on the resultant of forces that we will do in the next class, because we hardly have 10 minutes now. We will not be able to complete the problem. So what I'm going to do in this class is I'm going to introduce you to a new concept, and that is called as equilibrium. Are you with me?
Yes, sir.
So we will now discuss equilibrium, concept of equilibrium, and then in next class first we will solve few more problems on this and then on equilibrium. Are you with me?
Yes, sir.
Sure. So what is your notion of equilibrium? What do you think? What is equilibrium?
Sir, body in a state of rest due to equal action of opposing forces.
Okay.
Forces
No,
balance.
no. Omit the next part. Next part omit करो. That is the consequence of definition of equilibrium. Equilibrium का definition अब मैं आपको बताता हूँ, वो ध्यान में रखना क्या है equilibrium का definition. By equilibrium, what I mean is the body is either at rest or it is moving with uniform velocity. दोनों में से कोई भी एक कंडीशन सेटिस्फाई हो जाए तो मैं कहूंगा बॉडी इक्विलिब्रियम में है. आर यू विथ मी? बाय डेफिनेशन. सो क्या है डेफिनेशन? व्हेन आई से द बॉडी इज इन इक्विलिब्रियम, तो पहले तो मुझे ये देखना पड़ेगा कि वेदर आई एम सीकिंग इक्विलिब्रियम ट्रांसलेशनली और रोटेशनली. देखो क्या बोल रहा हूं. ट्रांसलेशनल इक्विलिब्रियम एंड रोटेशनल इक्विलिब्रियम. इसका मीनिंग क्या है वो समझने के लिए आई एम गोइंग टू स्विच ऑन द वीडियो. 1 मिनट. चलो. एम आई विजिबल?
यस सर.
हाँ, ओके. तो अब जरा देखो, ट्रांसलेशन का मतलब होता है ऐसे, 1, 2 या फिर 3. दिस इज कॉल्ड एज ट्रांसलेशन. आर यू विथ मी?
यस सर.
Translation is the effect of force. You will agree with me. If I apply force in this direction, there is a tendency to translate. If I apply force in this direction, there is a tendency to translate. Are you with me?
Yes sir.
Okay. And this is called as rotation. Rotation is effect of either moment of a force or moment of couple of forces. Are you with me?
हाँ. Yes sir.
हाँ. So दो तरीके के motions possible है. Let us say this is x axis. ये कौन सा axis है? x axis. Are you with me?
Yes.
तो x axis के along body या तो translate हो सकता है, देखो ऐसे. Are you with me?
Yes sir.
या फिर body x axis के about rotate हो सकता है.
Rotate हो
Are you with me? This is
Yes.
the rotation about x axis. Similarly, the body can translate about y axis or it can rotate about y axis.
Rotate.
Are you with me?
Yes sir.
The body can translate along z axis or it can rotate about z axis.
हाँ.
Are you
Yes
with me?
sir.
हाँ, ये दो तरीके के इफेक्ट हो सकते हैं. Now I will stop the video. So have you understood what is translation and rotation?
Yes sir.
So we have understood what is translation, what is rotation. Now we will define what do we mean by translational equilibrium. So let us say I am considering x-axis. Now I am not going to give you bookish definition ever in this class. Those are all useless definitions. आपको समझना चाहिए कि क्या है. So therefore let us say the body is, we are considering x-axis. Are you with me?
Yes sir.
If the body is at rest along x-axis, मतलब ये x-axis के along translation नहीं हो रहा है, ये एक कंडीशन है. या फिर if that means इसका velocity along x direction कितना है? 0.
0.
Are you with me? या
Yes
फिर
sir.
the body is moving along x-axis translationally, and its velocity is constant. ये दोनों चीजें अगर ये दोनों में से एक भी चीज सेटिस्फाई हुई तो हम बोलेंगे द बॉडी इज इन ट्रांसलेशनल इक्विलिब्रियम अलोंग एक्स एक्सिस. आर यू विथ मी?
Yes sir.
ट्रांसलेशनल इक्विलिब्रियम. ट्रांसलेशनल, जो बैच मेरे पास प्रैक्टिकल के लिए है उनको शायद मैंने ये बताया है, बट इट मे बी रिपीटेशन फॉर देम. इट्स ओके. ट्रांसलेशनल अलोंग अलोंग x axis. So it is in translational equilibrium along x axis by definition. ये definition है, इसको आप question नहीं कर सकते. जैसे somebody whose name is Samir, I have to call him Samir. I cannot question why should I call him Samir. वैसे ये definition है. Are you with me?
Yes sir.
Now what about rotational equilibrium about x axis? Let us say the body under consideration is not rotating about x-axis. So therefore, angular speed about x-axis is 0. Are you with me?
Yes sir.
या तो if the body is rotating with uniform angular speed. Are you with me?
Yes sir.
Then I call that the body is in rotational equilibrium
Yes.
about एक्स एक्सिस। हाँ, तो चलो अब y और z एक्सिस का सेपरेट बताने की जरूरत नहीं है, यही स्टेटमेंट्स आपको एक्सटेंड करने हैं। आर यू विद मी?
हाँ सर।
हाँ, now let me check if you have understood what I am trying to say. Now let us consider projectile motion. Are you with me?
Yes sir.
Projectile motion मतलब क्या? There is a stone and I throw it with initial velocity v. It follows a parabolic path till it reaches the ground. Are you with me?
हाँ सर।
हाँ, ये पूरा मोशन जो है वो प्रोजेक्टाइल मोशन है। नाउ टेल मी।
Sir, excuse me, sir.
या गो अहेड।
Sir, I am not able to see your screen.
Is it the problem with everyone? Others, are you able to see the screen?
Yes sir, I am able to see.
Okay,
Yes, sir.
so what I would suggest is you just log off and re-log in. You will be able to see the screen. Okay. Chalo. So this is parabolic. This is projectile motion. Are you with me?
Yes sir.
Tell me, the body is not rotating about XYZ axis. We are just throwing it. It is not rotating about XYZ axis. So is the body in equilibrium, rotational equilibrium about all the axes? Do you agree with me? Body is not rotating about X,
Yes.
Y or Z axis. So it
Yes,
is
sir.
in rotational equilibrium about all the axes.
Yes sir.
हाँ, rotational equilibrium तो है about X as well as Y as well as Z axis is prevalent. It is there in this case. Are you with me?
Yes sir.
Let us call this as X, this as Y, and coming out of the plane of both towards you is Z.
Yes.
Are you with me?
Yes.
Now tell me, is the body in translational equilibrium about Z axis?
Yes sir.
And what is the reason?
Sir, because it's only X and Y components are changing, sir. Z
No. Tell me in the terms of definition. Can I say at every point along this travel, Vz is 0?
Yes sir.
Are you with me?
Yes.
So as Vz is 0, therefore there is a translational equilibrium about Z axis. Do you agree with me?
Yes.
Translational equilibrium in Z direction. Okay. Is the body in translational equilibrium along Y direction?
No.
Why?
Because as Vy is changing.
Yes. So acceleration in Y direction is minus 9.81 meter per second square. Do you agree with me?
Yes sir.
इसका मतलब है Vy is not constant.
Constant.
Vy not constant.
No.
And therefore, no translational equilibrium in Y direction. Do you agree with me?
Yes sir.
No translational equilibrium in Y direction. And what about X direction?
Sir, no translational.
Pardon? No,
X
if we neglect the air resistance, Vx is constant. Do you agree with me? In projectile motion, horizontal component of velocity remains unaltered. Do you agree with me?
Yes sir.
Provided we neglect air resistance, and that's there. Yes, we are neglecting air resistance. If Vx is constant, then is the translational equilibrium satisfied in X direction? Yes, but the reason is different than Z axis. Z axis में क्यों है? क्योंकि Vz 0 है. But X axis के अलावा equilibrium क्यों है? Translational equilibrium because Vx is constant but non-zero. Are you with me?
Yes sir.
हाँ, so therefore अब जरा देखो translational equilibrium तो है X axis के about in X direction. लेकिन रीजन अलग है Z direction से. रीजन क्या है? Vx is not changing. Are you with me?
Yes.
So now look at the complexity of the problem in our hand. The body may be selectively in equilibrium either in translation or rotation about particular directions. Are you with me?
Yes.
हाँ, तो अब जरा फैन की तरफ हम ध्यान देते हैं. नेक्स्ट एग्जांपल इज फैन. आई एम फिनिशिंग विद द फैन एग्जांपल. So let us say there is a ceiling fan hanging like this. I am drawing its, okay, I am drawing its elevation. So this is the hook to which these are the fan blades. Are you able to imagine this? My drawing skills are very poor, but you have to understand. Are you with me? And
Yes, sir.
let us call this axis as Z axis. Are you with me?
Yes, sir.
And the fan is rotating about Z axis at a constant speed. So what is the equilibrium, whether the fan is in rotational equilibrium or about Z axis or not? देखो, WZ is constant.
Constant. Yes, sir.
So the fan, though it is rotating, it is in rotational equilibrium about Z axis.
Z axis. Yes, sir.
Are you with me?
Yes,
So
sir.
therefore, to ascertain whether the system is in equilibrium, either in translation or rotation, you have to look at either linear speed or angular speed. Linear speed or angular speed, अगर magnitude wise same और direction wise same रहे, तो equilibrium में है. Are you with me?
Yes, sir.
Zero रहे तो भी equilibrium में है. So this is the definition of equilibrium. Have you understood this?
Yes, sir.
Now in tomorrow's class, after solving few problems of resolution, we will now take this point forward in the sense that now we will see how the equations of equilibrium are manifested from this definition of equilibrium. इस equation के equilibrium के definition से how do we write equations of equilibrium? वो हम next class में देखेंगे. Are you with me?
Yes, sir.
Okay, so today we will stop here. Write down your roll number and name in chat box, and then you can leave the meeting. Once the last fellow leaves, I will stop the class. Anyone has doubt in any of the today's concepts that we have seen, you can ask now.
Hello, sir.
हाँ बोलो.
Sir, can you brief me again after rotation and translation, because I lost connection and got hand up.
Okay. So till which point you were with me?
So till translation and rotation part.
No. I mean, did you hear the entire definition of equilibrium?
No, sir.
Okay. Let us do it in this way. What is your name?
Sir, Kushagra.
Kushagra. I am sharing now in some time that this video lecture will be available. So I will share with you. Just listen to last 10 minutes and then let me know if you have any doubts. You can put WhatsApp message me or you can call me. Is it okay? Okay.
Hello, sir. Hello, sir.
हाँ बोलो.
Sir, for the system to be in system or any object to be in equilibrium, the forces should be in same direction if there are two.
No. Wait, don't go to jump to forces. The definition of equilibrium does not say anything about the forces. Whatever we write down, those are equations of equilibrium which are in terms of forces and moments. Those are the manifestations of definition of equilibrium. वो हम next class में करने वाले. Are you with me?
Yes, sir.
So forces का कहीं भी जिक्र नहीं होता equilibrium के definition में. That's why I asked you to omit the second part of definition. Equilibrium में forces का लेना देना नहीं है. We will only look at whether the translational speed or rotational speed is constant or zero. ये दोनों में से कुछ भी एक हो जाए तो equilibrium है. अब force उसके लिए forces कैसे होने चाहिए वो बाद में देखेंगे. That is the manifestation of definition of equilibrium. Are you with me?
Okay, sir.
Or those are the consequences of definition of equilibrium. That we will see in the next class. Next class में जब हम equations of equilibrium derive करेंगे, उसके बाद भी आपका डाउट अगर कायम रहता है, then पूछना. Are you with me?
Okay, sir. Yes, sir.
Okay.